Relax it, we'll be better next time I try. And even if I still can't do it, yeah, you know that I'm gonna stick to it. Yes, it's all about going through it, and I'm gonna tell you why. Whoopsie, whoopsies, I made a mistake and it's okay. It's okay. Whoopsies are what it takes to get better and better every day. Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo! Whoopsie, 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 whoopsies.
I'm a little embarrassed when I look at my drawing compared to this. I'm just not getting anywhere with this. It makes me wanna hide. Aw, don't be embarrassed. Don't hide.
You should have seen mine the first time I tried. It took a lot of whoopsies to look this way.
No one's perfect on their first day. Whoopsie.
Whoopsies, I made a mistake and it's okay.
It's okay. Whoopsies are what it takes to get better and better every day. Whoopsie, 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 whoopsies.
Well, what about this? I want to jump rope, but nope, I just can't do it.
Well, not yet. Come on and practice with me. You'll see there's nothing to it.
Whoa! Whoopsie.
Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo!
It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. I know it's hard, but for long, before it's too dark. Wake up, my love, please don't give up on me. It's hard. Wake up. It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. But I know it's hard, before long, before it's too dark. Wake up, my love, please don't give up on me.
What is up? What is up, you guys? We are back at it again. Another day of 100 days of rootkit. Now today, we're gonna be getting to implementing our database with one of our pre-existing games, showing how that whole connection goes on, how it happens, how to go about stitching everything, make it one big old cohesive unit. All right, it's going to be super fun, super exciting today. Let me go ahead and pull up the YouTube's chats and the Twitch chats here. Give me 2 seconds. There we go. There we go. Alrighty, before moving on, let's go ahead and do our little intro here, shall we? If you don't know, we are Rootkit, a nonprofit here in the US of A. We're going to teach you everything you need to go to get one of our certs. Our certs are the best in the industry, period. There is no ifs, out. I just forgot that whole term. We're the best in the industry. Don't go to college. Do not go to any other boot camp. They are trash. They are trash. They're not going to give you what you are requesting from. They are straight up scams. All right. If you want to burn through $100,000, I'm more than happy to take your 100K. All right. More than happy to take your 100K. Instead, look at that. We're streaming here live on YouTube. They're all recorded if you're watching after the fact. You can learn everything you need to know to get our cert, get certified, and then get a job. It's just that easy. It's just that easy. No strings attached. All right. Additionally, we have our giveaway, which I have. It's there. I just didn't turn it on. So maybe during the break today, I'll turn it on. So when we redo this after the break, it will be turned on. We have our giveaway completely free. All you have to do is subscribe to our YouTube channel, follow us on Twitch, yada, 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 and then go to the blog link and prove it. Right? Prove it. You just click on a button and you just prove it. All right. Additionally, there's a link in the description of this video. And if you're on Twitch, somewhere in there, all right, somewhere on the bio, if you go to the charity stream, again, we are a charity, which means every dollar you donate means it don't go to Uncle Sam no more. They don't know what to do with your dollar bills. All right. They suck. They are absolutely, I don't care what government you're part of. They all suck. They don't know what to do with your dollar bills. All right. They burn them. They absolutely burn them. So instead, save your dollar bills. Donate today. Avoid on your taxes if you're here in the US of A. Depending on how much you donate, you can unlock certain rewards like our Epic stickers, our collab t-shirt, and our exclusive 100-day of Rootkit sweater. It's been a while since I showed off the stickers. I mean, you can see them there in the picture, but look at that. Look how cute it is. All right. Additionally, all donations are matched 1-for-1 for the first 10,000 donations. So every time you donate, it's like donating twice as much. And we got pillars along the way, like teaching for 24 hours straight, shaving my head here live on stream, and shaving my beard. All right, shaving my beard, which no one wants to see except for my mom. So we can disappoint her. It's okay. All right, it's okay. All righty. Let us continue on here on our journey today. We're going to be integrating our database. Let me go ahead and mute that. Integrating our database here with one of our pre-existing 100 days of Rootkit programs. I believe we're going to start off with the word guessing program and show how that whole cohesion happens. All right, how that whole cohesion happens. Because I kind of hinted earlier that, files are databases. All right, they store information that you can then recall later. Databases do the same thing, except in a very smart and powerful way, which allow for lots of perks, mainly speed. Speed is extremely important, all right? No one wants to be sitting there waiting for something to load, all right? They want it quick, fast, in and out, 10-minute adventure, all right? All right, so let's see how we can start all this up. Let's go ahead and pull up dbeaver here. And make sure we're connected to our database. And we're going to have to create some new tables here. All right, we're going to have to create some new tables here. If we can connect up any second now. Oh man, and I forgot my coffee in the other room. Oh boy. All right, that took 20 hours. Here we go. Well, is it still? It is still connected. I'm so surprised. I've restarted my computer and this thing, I guess, is just auto starting every time. Very, very convenient. All right. These tables in here, we're not going to be using because we don't have users and tweets per se on this program. So we're going to have to make more. All right. And again, sorry, I can't really zoom in dbeaver here. So this is what we got to work with. But let's take a look at our word guessing game here. All right. So either if you're trying to integrate after the fact I feel like this camera keeps pointing up higher and higher. Now I feel like it's super low. Is it just me? All right. So when you're creating a database and integrating your application, there's several, depending on, your situation, you may be creating the database beforehand, or you might be creating or adapting to it in the middle of, or making it after the fact. What does that mean? Making it before you've made your program, making or updating it during you making your program, and then integrating the database at the end of your program. All right, so there's usually 3 ways you can go about adding it. The best way to do it is initially up front, followed by any potential updates it needs along the way. All right, we are all human, so it doesn't matter what level you're at, from beginner all the way up to top end, high, pro, hacker, dev. All right. Sometimes it's hard to think through everything you'll need, and you'll need to retroactively add more stuff to the database. That's fine. It happens. It's not that big of a deal. It's best to try to lay out everything as clean and best as possible up front so you can save yourself headaches down the road, because databases are not something you want to mess up the layout, because if you mess up the layout in the sense that it's not dynamic enough to adjust and adapt to things or changes you want to make later on, it's not a fun remake. All right, it's not a fun remake, and potentially how much data you have in that database, it could be a lengthy process because you'll have to move data around, and there could be potentially gigabytes, terabytes, petabytes of data in your databases, and that's going to be a long process. All right, a long process. Before we continue, I think I forgot, I am in the events chat, so if you jump into the events voice channel here in the Discord, you can go ahead and chat away. You can go ahead and chat away if you're a Patreon or Discord premium member. All right, so let's think through this a little bit right now. So it is valid to have just a file that is a word list, drop it, and have it work in this program, because that's what we're doing right here. We have a file that's called word list, which is a list of words, each one in a new line. All right, that is valid and that works. This does not need to be a part of the database. It can, it doesn't need to be. We're going to make it a part of the database, not because it needs to be, but because we can. And this is all about learning about databases right now. So we're going to do it. All right, we're going to do it. We're going to add this to the database. So we need something in regards to, so let's make some notes here and keep track of what we need to do. All right, because not all of us can memorize everything at once. It's best to keep notes. So let's see, database update.txt. All right, so we want our words in a table. All right, we want to add our words to a table. Additionally, we do have that score mechanic, so we can track scores, and scores are like the old arcade scores, where a score is given and then you can do some type of name, and it has no ability to remember or recall per se the user in another session. You just play until you're out of the game, and then you get your score and you save it, and then that's it. And if you want to go again, then you have to play again and put in your name again, and there's no cohesion behind the names, right? There's no cohesions behind the names. So this is going to be very, very simple for us, right? Compared to what it could be in regards to recalling people. So we need a database to store people's names and their score. Whoops, messed that up. So we need we need another table for names plus score in a table. All right, so it looks like we need at least 2 tables right now. At least 2 tables, right? Any questions on this so far? Let's see here. Any other? I think that's just about it for this game. Any questions so far with that before we chug along here? All right, so let's go ahead and continue here. So we know we need 2 tables, at least it seems like it. All right, I'm saying that not because there might be more tables, but we don't know until we think about it a little bit more. All right, so words in a table seems self-explanatory enough. This, for our case, will be very simple, but it could be way more complex. So in our case, again, like I told you guys, all tables by default, if you're ever in charge of making tables for a database, which please have a mentor or something help you out, unless it's for your personal project, then experiment away. All right, but if you're actually at a job, get someone else's opinion. All right, by default, you should just always have an ID field or a column, ID column that will be an auto incrementing ID. All right, it's better to have it than not have it, at least for right now when you guys are learning about databases. All right, so we're just gonna add that in there because why? Elijah said we should just always have it right now by default until we learn more about databases through our practicing and on the job, experience. Additionally, we need the word. All right, so we need the word itself. All right, we need the word itself. This is all we need for this use case, right? For our game here, our word guessing game. Simple enough, right? Simple enough. Now, if this is going to be something more in a production work case, so in the real world, it would not be this simple. You could make it this simple, but if you did, it may really come back to bite you in the ass, all right? Because what if this game is supposed to be for kids and someone goes in there and adds fuck, shit, and goddamn hentai, all right, and goddamn, all right? Oof, someone's gonna get fired. Who's gonna get fired? Oh, the guy who entered it. There's 10 people that have access to this database. Who entered it? You don't know? Exactly. You don't know. A whole investigation has to happen now. All right, a whole investigation has to happen, and maybe, hopefully, your IT person set up for there to be network logging internally, so you can see who is maybe communicating to what and sending this traffic across your internal network. But if not, you're out of luck. You're out of luck. Someone did it. Until someone owns up to it, you don't know who did it. All right, you don't know who did it. So first of all, having direct access to the database should be extremely limited to probably 1, if not 2 individuals, and they should have their own unique accounts. All right, that is a completely advanced tier database stuff. We're not going to talk about that. 2, if you're using a portal for someone to add words to this database, so maybe it's a Python program where, I'm one of the game designers and I want to add new words, all right, then I shouldn't be adding them directly to the database. I should be going through a Python program or something to add them to the database for me, all right? When that happens, I should be logging in with some type of creds that show remember the 5 pillars we talked about in the CIA triad? That's the whole part of this, right? Data. You need to be able to have the data non-reputable, right? Or you need repudiation. Is that the right one? Repudiation is the ding 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 word today. All right. Who did it? Who did it? So, and you need to guarantee they're the ones that did it, right? You need to guarantee they're the ones that messed up the game. All right. Send all these young innocent children all these colorful words. All right. So it would be ideal for you to have maybe like the user ID, because remember, we don't add the user themselves. We need a user table, and that we refer to the users in that table via their ID. So in a more appropriate corporate setting, we would want the user ID logged here. Additionally, when did they do it? We would want to have a timestamp, stamp of like maybe when they added it. So you can have a timestamp of added, and if it was ever updated, maybe there was a typo. All right, you would want the timestamp of last updated. Additionally, this brings you to an entirely another option of having a second table. Why? What if I update the word 2 times? We only have here last added or last updated and added. What do we add more columns? No. You don't add more columns, all right? This is a part of the database structure stuff. When you start seeing things not being dry, it means you need a new table. So it may be appropriate in a corporate setting for you to have another entirely new table called words edit. All right, and in this words edit table, of course, we have an ID just by default. And here we would say the word ID, the user ID who edited that word, user ID, and then maybe the timestamp, they edited that word, and that would be pretty much it. And you would add a new record to this table every single time a word gets updated or edited. All right. So if you updated or edited a word 1,000 times, you just make 1,000 logs in this table for it. Right. So this is what I mean by look at your tables after you write down all of them and really think about them. Really think about what you may need or what additional tables you may want to create. Again, this overkill for what we're about to do. But in the real world, this is not overkill, right? This is something you need to think about. We teach the CIA triad and the 5 pillars of integrity. God, I'm forgetting the term for it right now. For a reason, because all those things you want to be hitting. You want to be hitting on. They kind of seem kind of silly and really big, fancy, like crazy words when you're first learning them, but they're very, very important, right? Because again, who did it? Who made the oopsie? And was it this is especially bad if it was even more, I mean, that's pretty malicious if they're trying to do that to a kid's game, but like if it gets even more malicious than that, like you got to know who did it, when did they do it, you know, what time, whose account, etc., etc., etc. So think about those things, right? Think about those things. All right. Any questions on that, I guess, before we move on to our names plus scores? And again, if anyone's asking questions, go ahead and keep asking questions. Again, the best way to get good at this and learning about it is just by programming. By programming, by making things, by messing with databases, by experimenting, if you're on teams with other people, look at what they did. Ask them questions. Ask them why. Ask them, why do you do this? Why do you have a timestamp added? Why do you have a last updated? Ask them. If they can't answer those questions to you, they might not be that great of a dev, right? They should always have a reason of why they did it. And if they don't, or if it's not a good enough reason, then let them know. That's not a good enough reason. They need to figure out why, right? They need to have those answers. So if they don't have those answers, they're on autopilot, or they're just doing whatever habits they've developed, right? All right. let us continue on here, shall we? All right, so our other table here, names plus score in a table. So what columns do we need here? Well, you guys should all be saying one column at least, all right? That's right, the ID column, right? Always put that ID column, all right? Always put that ID column, at least for now, It's better to have it than not to. Now, next, well, we know we want to log their score. So maybe we just have a score, and then maybe we just have their name. Yeah, seems simple enough to me. This would, I would say, would be maybe, no, this is just for high scores. So that would be fine. Because the only, oh wait, we're on the code already. The only other thing I would say is, I guess you could track real time, like their progress, and log it in the database. And then display it, but we're not even doing that here in the game. So let's just keep it simple. All right, let's just keep it simple. And yeah, that's all we're doing here is name and current score. Again, oh, I keep thinking this text file is on something else. All right, so again, if this was in a more professional, game setting, because we're just learning right now. All right, if you want to remake this game in a more release ready state, I mean, it is technically release ready right now, you could try to make money off of it. You may want to have it so users like log in and you just update their high score, or you constantly log new high scores they have. So instead you would want, your high score table to be, again, we put the ID in there. We're gonna have their score here, but instead of their name, that's right, you'd want the user ID, which refers to a user table, which has all of the user's information. And then maybe also here you would want a timestamp. All right, this is maybe when they scored this score. So that way you can keep a bunch of high scores for the same user, and they can see their progress over time, if they're getting better, worse, stagnant, etc., etc., etc. All right, so that's more of the pro setup if you're going to keep going on. I would highly recommend, if you guys want challenges, there you go. You got 2 challenges right there for adding words and to the database, and for users who are playing the game. Again, you don't need to, in your testing, purposes here, if you want to do the challenges, you don't need to hook this up to a whole big login system. You can easily just have it so people have to enter a username and that's it, and then they get logged in. Or maybe it's a username and password. Don't worry about encrypting it or anything like that. Just store it in a text file. Just use it internally. Don't distribute it, right? Don't distribute it. All right. So this looks about right. So the next step, after we think through our tables, see what we need. Technically, we could have the time in here. Timestamp. We'll put timestamp in here. So once we sit here, we think about what we need for our tables, how many tables we need, etc. Spend as much time as you need on this step, right? It's not as straightforward as you may think sometimes. Sometimes it may take a couple hours to really think through it. Again, these are the thinking parts of programming. It's the mental game, all right? Not everything is about working and working and working. Sometimes it's about just sitting there and acting like, that one sculpture, the thinking sculpture, where you're just sitting like thinking, all right? That's sometimes what the job is about, is just sitting there and thinking, all right? And trust me, thinking is very tiring, all right? Very, very tiring. To the database, as in SQL, sorry, got in 10 minutes late. Not sure what we're talking about. I'm trying to follow along though. We haven't done too much. We're about to add these tables, all right? I highly recommend you rewatching though, because we did cover some good stuff. We did cover some good stuff in these tables. So next step, we load up our database. We need to make these 2 tables, right? So let's go ahead and make a new table. So we right click on tables, all right? We click on the button that says create new table. At least if you're using dbeaver. This would be different if you're using a different application to view the database. Again, you can use anything you want. All right, this is just free and readily available. There are lots of database viewers out there. So let's change this table's name. and we'll make this one the words table. So we're going to call this words. All right. And in here we have our columns. We have no columns right now, so let's go ahead and right click. All right, we're in the column section right here. So let's go ahead and right click. Is it in my head? No, my head's not blocking this. And we'll click on create new column. In here, this column is going to be our ID column. So we'll just go and say ID. IDs are going to be always of type int. So we'll go ahead and do int. Wait. For Postgres, I think this was some weird special. Let's refer to one of our other databases here, shall we? Why are you saying there's properties? There we go. Serial 4, that's what it is. Serial 4 for Postgres, right? So we need a serial 4 data type. Or I guess serial 4 is the amount of bytes we're using. So we just need a serial type. All right, so let's go to data type here and type in S. Here we go. We got serial, so I'm just gonna click on serial. Rating with a party of 83. My God, what is up, you guys? What is up? That is a massive rate. I hope you all are doing good. We're just going over SQL databases right now and integrating it in our Epic application. My God, who sent you guys? Anthony writes code. Thanks, buddy. Y'all are crazy. This is the first time Twitch has popped off. Hey, YouTube people are super awesome, all right? But Twitch, hey, it's finally popping off, I guess. Anthony told me to say hi. What's up, you guys? What's up? Anthony, are you in our Discord? Or have you just been like watching every once in a while? I'm so confused. I'm so confused, you guys. So real quick, let's finish up this table for you guys. So make sure you choose that serial data type value with that ID. And we can go and click on not null because this should never be null. All right. And we'll go and click on OK. Then let's go ahead and add a new column. All right. Because we established here, we need that word column. So let's go and right click again and create a new column. And let's call this one our word. All right. Let's call this one our word. And in here, we can have this as our varchar, our variable char, because we don't know how long or short a word might be, but we know we need to add a word. And we should definitely click not null for this one too, because we should never not have a word in the record, right? There should always be some type of word in there. Serial something, yeah, just serial is fine. The number at the end of serial is going to be how many bytes of data it's going to take up in the database. So you can there should be an option there for just serial, but you can also select 4 or 8. I mean, you could do 2. We're not going to be doing anything super crazy. So you could do 2 bytes, but usually you want to do 4 at a minimum if you had to choose a byte amount. So let's go and select not null here. There we go. There we go. Y'all are crazy over on Twitch. My God. Once we're ready for this, we'll go ahead and either click the save button down here or Control S, all right? The save button down here or Control S. So let's go ahead and click on the save button here. And again, for you to start learning up on all your SQL, dbeaver is really nice. This is pretty common for a lot of these database viewers. They'll output to you the SQL, so you can look at it, start learning it, copy it, paste it, maybe add it to your code in here. So much so this is potentially useful. I actually want to do this right now. So I would highly recommend copying it and then persist, so that way we persist it. And now we can paste this off maybe in our database text file here for later use. What later use may you ask? Well, what's the number one thing for being a programmer? We want to be lazy. Programmers are lazy people and we love that, all right? We don't want to do extra work if we have to, all right? What if you want to give your buddy this program? if you want to give your buddy this program, you have to go in and create this whole database again by clicking on things, right click, X, Y. Ugh. All right, that's work. We don't like work. So what we can do instead is, since we have the SQL here, if we save it off, we can make potentially a script, like a Python script, for initially creating this database for us, so we don't have to create it by hand later on. AKA, we get to be more lazy and have a more robust program. So it's a win-win-win for everyone, all right? Win-win-win for everyone. So is everyone caught up right now? Any questions before we chug along with our next table here? What are we doing? We are programming. We're learning SQL right now. Well, we learned some SQL earlier. Right now we're showing how to integrate that with the existing programs that we made earlier in the 100 Days of Rootkit event. So we're going over how to add it to our word guessing game. And after this, we're then going to show how to add it to our dungeon crawler game, and how to kind of make tables, think about making tables, etc., etc. I like what I'm hearing. The lazy part, that's my favorite part. That's my favorite part. ID is serial, correct. The words is a varchar, correct. Yep, not an archer, sorry, not an archar, a varchar. Let me go and type it in, varchar. Yeah, I know, I'm sorry, it's small. Here, I can zoom in just temporarily for this DB part, because, yeah, like I said before, you guys, the database stuff is just really small. I can't do too much about that for at least dbeaver. Hopefully that helps out. I'll have to zoom this back out when we get back to the Python section though. There we go. Hopefully that helps a little bit more. So you can kind of see the data type name right here. All right, so if Anthony was here, he would comment on your file name casing. Is he a snake or a camel person? Because I like camel, so I usually keep the camel, but in databases we're going to be using snake. All right, so let's go ahead and move on here. So we need to now make our second table, all right? Our second table. We made our words table, which is for adding all our words to for the word guessing game, and we'll be pulling words randomly out of this table. Next, we need to store all of the scores. We got to store all the names and the scores. So we got to make that table. So let's go ahead and make this new table. And for this table, we're going to be putting the scores and the names. So let's just call it our high score table, all right? So let's say high score. After we do that, what's the first thing we're going to do by default for now? That's right, we're going to add our ID column, right? We're going to add that ID column. So again, make sure you're in the column section here, right click, and we're going to create new, oh, I moved this. There we go. We're going to go and create a new column. We're going to call this our ID. And then since we're in Postgres right now, we're going to change this to serial. And again, this is a Postgres specific thing. This is not in every database. Most databases, you're just going to have this as an integer, and then you'll set it as your primary key afterwards, which I think we missed that part for the words database. So we'll have to go back to fix that part. Don't worry about it right now though. So let's go ahead and set this to not null also. All right, after that, we have our scores here on our notes. Oh, that's why I moved this over, because we have our notes here. Let me move this. There we go. We got scores, we got name and timestamp. So the score we know is going to be an integer value. The name is going to be a varchar. And then the timestamp is going to be a timestamp. So let's go ahead and create those. So let's go ahead and do the I'm already forgetting all of them. Let's do name. Let's do name, varchar, and not null. Then we'll do a new one for score. And we're going to have this as an integer. And remember, this should be an integer because it is possible to have negative scores. That's right. If it's not possible to have a negative value, then you should do an unsigned integer. All right, you should do an unsigned integer. Like we showed when we talked about C, you get double the amount of room for values. So in the same amount of space, you get double the amount of values potentially. So make sure you're using the right value, all right? So let's go and do not null. And then last one, let's do our timestamp. And this one, I think there's something literally called timestamp. There is right here. So we'll click on the timestamp and we'll say not null. There we go. So it looks like we got our table here all up, prepared and ready. So let's go ahead and save. All right, we got our SQL preview that gets outputted right here. So let's go and copy that over to our little text file for us to refer to later, so we can make that startup creation script. Most likely we'll make it like a function that gets called at the beginning if this stuff doesn't exist. All right. So we'll go and click on persist, and now it's created. What questions do y'all got so far? Again, we have to go back to make sure our keys are set up because they're not set up right now. So we'll have to go do that. But afterwards, we're pretty much good. We're ready to start integrating this in our epic program. I hope you all are hyped. You good, Kamal? You have any questions before we chug along? I don't want you to be lost in the sauce. All right, you say something if you need some help. All right, we're gonna continue forward. So I'm gonna go back to the words table. All right, so let's go back to the words table, and we need to make that index, right? Because again, if we don't have an index in our table, it's fine. It will work just fine. All right, there's nothing really dire about it. The only thing is we're losing a lot of the efficiencies, and the whole point of using a database is those indexes, that quick and rapid searching, all right? Using those binary search trees, all right? That's the whole point we're using this. So we should definitely activate them so we can use them. So it's always good to have indexes at least on your ID, and your ID should typically always be your primary key. So if we right click on our ID here in Words, we can say there's an option here for new constraint, all right? New constraint. So that's the key buzzword here for creating your primary key, which will automatically have an index created from it. All right, it's just an automatic thing that happens. So let's go ahead and click on our new constraint for our ID. All right, and this is going to be our words primary key. So it automatically made a name for it here called words_pk for our primary key. And we'll go ahead and say, okay, easy as that. Now we just need to make sure we persist this. So you can do Control S or press the save button down here at the bottom, which didn't realize it was almost being cut off of me. It's right below the banners here. So let's go ahead and save. And you can see we get some more SQL output here. So we can copy all this. Oh, took away the box here. We can copy all this and put this in our little file here for reference later. All right, I put this over here in the Word section. Let me go and save this file just in case. And now we can persist it and we're good to go. If we look in constraints here, we can see this is now our primary key. And if we go to indexes, you can see an index has already been created on it. Super nice, right? Super nice. So we're going to do the same thing over in high scores for the ID. So we're going to right click. We're going to go to new constraints. And then we're going to go the high score underscore PK, primary key. All right, it should be a primary key. Again, you can make more than just primary keys here. And we're gonna click on OK. Then when we try to save it, we'll get this text that shows up. We'll go ahead and copy that and paste it into our little text file here for reference later. And then we'll click on the persist button. So again, all we're doing here is setting the ID for both of these tables as our primary key and then saving it. And bam, it's now a primary key and it's automatically indexed. Now, the words table, I personally wouldn't do any more indexes, but for your high scores, you don't have to, but you could add more indexes here depending on how you want to search for scores, right? If you want to search for scores by maybe what score is the highest score, or maybe by user names, like the names that are entered in here, and that's like a common occurrence, you may want to index on those. Again, you don't have to, but by default, that's going to be an O of N operation. It's going to be kind of slow as you scale up in data. But if we want it to be faster, we can index, so it's instead that log of N operation. So we might do indexing on our scores here, only because I think in our game at the end here, we'll probably output the highest scores, or just have the highest scores being outputted. So we need to quickly recall what scores are the highest. All right, so if we right click on here, we don't want to make a new constraint because we're not making this a key. We do want to make this an index though. So there is a button here for new index from selection. So we're going to click on that. Alternatively, you could click on the index tab here and right click and then click on create new index, right? Both are valid, both will work just fine. So it says what table, right? From the high score table, what type, right now it's grayed out. I think we have to select what column we want. So let's look through our columns. We know we want to do the score column. So let's go and check that one. All right, and it looks like that is it. This is not going to be unique, so we don't want to make sure this is not checked here. And we're going to click on OK. And there we go. It has been created. When we click on save, we're going to see some more SQL is created here. Let's go ahead and copy that and put it into our notes. All right, put it into our notes here. Is this? That did not copy. There we go. And then we're going to persist. Bam. Now we're done. Now we're done. So our table is now all set up and ready to go. Again, the index parts are not required for you to start using the database in a powerful, meaningful way, but you're going to unlock that extra little bit of power, not extra little bit, like a lot of bit of power from the database. It's different for Mac. There's no option for other list of keys. So there's just unique key. So if again, there's the index tab here and there's the constraints one. So go check your constraints constraints tab and see in there if it was automatically created for you. If nothing is in here, then try to create a new key right here. Additionally, look, I don't use Postgres that often, so I would assume maybe next check and see if you're using the serial type of data, because it may be looking for that serial type data. I'm pretty sure it wouldn't really matter, but you can just write the SQL versus using the GUI to do that. That is true too. That is true too. Right now, we're teaching people on how to do all this. And so I personally think it's easiest to first learn SQL through using the GUI and then looking at the auto-generated SQL and then messing with it from there. But I mean, I've learned not doing that way. I learned doing it manually way. But we're always trying to mess around and see what sticks best with people. So let us see here. Hopefully that brings up the extra options Kamal for you in this little type section. Yeah, I got it. Perfect, 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 perfect. Thanks for that input, Zeus. All right, so let us continue here, shall we? Let us continue here. So we got our table all created. LOL. Are you trying to say lol but like spelled out? I don't like that. I don't like that at all. All right, let me go ahead and fix my monitor here so we can that doesn't seem right. There we go. And bring this down. I feel like, is this messed? Oh, no, we're good. And shrink a little bit. And let's get the bottom one. All right, I think that's good. All right, hopefully. Hopefully, we'll see. All right, let's go ahead and go to our game here. All right, let's go ahead and go to our little game here. So, the first thing we're going to notice is we got to replace our word list. And our word list has a lot of words in it, right? It has a lot of words in it. It has 178 words, right? 178 words. Now, you could totally add all these words to the database by hand, right? You can totally do that. That would be cancerous, right? And what do we like as devs? That's right. Number one thing, we want to be lazy. That's not a very lazy thing to do, right? That's not a very lazy thing to do at all. That's a lot of hard work. We don't want to do hard work. We want to avoid it every chance we get, all right? So instead, it would be easier if we wrote a program to do this for us, right? Wrote a program to do this for us. Now you can start seeing here that your simple program, like a word guessing game, can easily start becoming larger and larger because we added a database and we want all these little automation things and we have a word list file. This is how your programs, you know, when you look at them on GitHub or you're making them yourself, you know, this is how they slowly grow in size and complexity. No one wants to make something that has 1,000 files, you know, different files, you know, at the beginning, all right? But it just eventually turns into that because you kind of just need them as you go along here, all right? And that's why also we hit on, like in our dungeon crawler game here, on the organization. There's nothing that's going to hold you to organization, right? There's nothing that's going to hold you to organization. But it's very important that you start getting good at organizing things, at sticking to a naming scheme, all right? However you want to choose it, because again, your variables are totally up to you on what you call them and how you go about doing it. But sticking to a scheme and how you want to organize things will keep it so the clarity is as high as possible, all right? So that way, other people that look at your stuff can, maybe it might be confusing at them at first because they're not used to your layout or the schemes that you use, but they can easily adapt to it, all right? And also for you, when you future you look back at your code, you don't have to struggle. We have not the best looking layout here in our word guessing game because this is towards the beginning, all right? So maybe we can spend some time here in a second to clean things up. Before we do that, we got to make a new script, all right? We got to make a new script to take our word list file and transfer everything to the database, all right? So we're going to make this a script and we'll call it maybe a word list transfer. Word list transfer .py. And in here, we want to transfer all those words to the database. So the first step we're going to need to do is going to be connecting to the database, right? Connecting to the database. And after we've established that connection, we say, hello there, Mr. Database. Then we can start communicating and talking to them and transferring this data over, right? Transferring this data over. So hopefully that starts, you know, kind of in your head, you're starting to see how the program is going to be laid out here. Now, number one thing, we like to be lazy as devs. Number two thing, or I guess number one thing, depending on how I feel when we're talking about it, we love stealing. We're little thieves. So let's go ahead and steal how we connect to the database from some of our earlier code, all right? Because we're all about that copy and paste game, right? So let's go ahead and look at our Postgres stuff from earlier. Let's go ahead and copy all this. Let's go ahead and paste all this because we don't want to write this all out. We've already done the hard work, right? We've already done the hard work. So let's go ahead and copy and use it as our starting place. So first things first, we got some code in here we don't need, like this user input part we don't need right now. Or maybe we do. Maybe we might want to use it for adding the words to the database, right? So maybe we'll just take note of it, aka we'll comment it out, and we'll move it down here towards the bottom. Next, we don't really want to be printing out the results, so we can kind of remove that bit. So we can remove this print statement, and this needs to be commented out, and we'll just add a comment here for refer to when adding. And the last thing is just like opening and closing a file, we want to make sure that we are closing our connection at the end. So let's go ahead and do our close here. So we have the outline of our little program here, right? The outline of our little program here. This shouldn't be anything new for you guys that have been following so far. You should already have this code. And all we're doing right now is importing that Psycho PG2 library. We're using it to help us connect to the database, create a cursor, which then we can use to interact with the database, and then we're closing our connection to the database. So we're saying, hi, Mr. Database, and bye, right? Nothing crazy, right? Nothing crazy. Now we need to make additions. We need to make additions. Additionally, we could use this to generate those tables, right? Generate those tables for us automatically. How would we go about doing that? Great question. We've already copied and pasted and stolen all of the juicy details we need in our text file right here, right? For creating that word table. So let's move it right here. So this is how we created our word table, all right? We created our table with an ID and word, and then we altered it after the fact to make a primary key on that ID column, right? So we could execute these also ourselves. So if we want, we could, again, like we've gone over before, and you can see here, and we can also reference our, where to go? Our code right here for execute. How do we run SQL? Well, it's that .execute command. So if we do cur execute, in here we can put a string with our query statement. So we'll go ahead and maybe add this table one, and we're going to do that triple quotes here, so we can kind of format it a little nicely. All right, let's erase our reference here. I'm going to comment this one so we can see if it's working or not. So we have this, so it will auto create this table. Now this will fail because we already have this table created. So it's going to try to create a table on a table, and it won't work. But also remember that this, just like what was the other one that I was referring to the other day? Just like Git, right? Just like Git, you can perform something, but it's not actually saved. It's not officially saved until you officially save it, right? Using a commit. Remember, commits are your official save, your official stamp on it saying, hey, let it be saved, let it be known. We have to do the same thing with the database here. So just because we're running this execute statement doesn't mean it's saved, all right? We have to run that commit. Now, we can run the commit just once at the very, very end if we would like. You can also run the commit after pretty much every statement if you want also. So let's go ahead and add our commit just right here for now. And remember, that's going to be on the connection itself. Now, let's go ahead and run this, and this should fail, right? This should fail. And again, remember, failing is good. You should be failing a lot, especially when you're first learning. That means you're doing things, I mean, not right, but you're learning, right? You're learning how to not do them that way. So we need to cd into our word guessing folder here before continuing on. And let's go ahead and run this word list transfer file. And you'll see here when we run it, right? When we run it, you'll see that the relations word already exists. Interesting way of putting that error message. If we look before that, you'll see what I really want to see, duplicate table, right? The table is already created. So we're trying to create a table when it's already made. Now, there's a couple ways we can go about dealing with this. Just like everything in programming, there's a bunch of ways to deal with every single problem. Before we talk about that though, what questions do you guys have so far before we chug on? All right, what questions do you guys have so far before we chug on? How are you doing, Kamal? Just wait a little bit here for questions. You doing good? All right, perfect, perfect. Trying to catch up real quick. Yep, go ahead. We got a little bit of a break here. See if there's any other questions before we chug along. All right. So, as with everything, there's always a couple ways to going about it. If we want this to potentially be the script that auto adds all the words but also creates the tables, it's totally up to you on how you go about it. You could have them as two separate files. You could have them as one file. It's 100% up to you. There is no rules, regulations, or guides that you have to adhere to. It's whatever you want and will into existence. So, additionally on that, so let's executive decision here. Let's make it all one file. All right, let's make it all one file. When we want to run these, when do we want to run these creation statements? Every single time we run this? Do we want to run it only when we set some type of flag that says create the tables? That's totally up to you too. That is totally up to you too. Me personally, yeah, run it every time, I guess, because remember, we learned about those statements the other day, those try and accepts, right? Tries and accepts. Now, having, again, like I mentioned with the tries and accepts, having those errors pop up and handling them gracefully is good, but it is still a very aggressive, nice process to your CPU. It's a really slow thing, right? It can really slow things down. But we're only running this once. We're only going to be expecting to run this file once, and it should only be hitting these and potentially airing out once, right? So it's not that big of a deal, and it's not that big of a slowdown for us. It's not like if it was in a while statement where it's continuously throwing up errors, and things are just going to go really, really slow. They're going to chug along. So it's okay to do it in a situation like this. So let's go ahead and put this in a try. So we're going to try to create the table before adding the words. If it fails, it means the table, hopefully it means the table is a-okay. And if it doesn't fail, then it means that we've created that table. Additionally, there could be other things that went awry, right? There could be potentially other things that went awry with us creating this table, not just the duplication table error. How you can, again, be precise about your errors is when you do that accept, right? You could just accept everything, all right? Or you could do that exception as E, and this is your catch-all. All of your exceptions will be handled right here. Technically, the only exception we want to be okay with is that duplicate table error. So if you want to be more precise, you could say in here instead, sciops.error, errors, is this going to work? Duplicate table. I don't know if this is going to work for this one. We'll see though. We shall see. Let's go and just put a print statement in here and see, did it work? Question mark. And let's go ahead and just add another except at the end here for exception as E. And let's go ahead and say, no, it didn't. All right. So we're just going to be trying stuff here. This is supposed to be errors. Where did this come from? Great question. This came from this name right here, right? Because this is a custom error that's being thrown. A custom error that's being thrown. So this should be handling that custom error, right? Because if this custom error happens, then we want to handle it. And this is the one we want to be okay with. If a duplication table error is happening, that means that's just fine. And we want to keep moving forward and add the words. If it's something else, then we don't really know what went wrong. So maybe we want to stop the program here right now. If this doesn't end up working, then we're just going to do an exception and catch everything. But in the future, as you guys make your programs and progress forward on your careers, you want to make sure you're using things in potentially as a precise fashion as possible. So let's go ahead and rerun this. And it said, did it work? It looks like it worked, right? It looks like it worked. So typing this out gave us our handler for this exact error. So now with that information, we can go ahead and we can state here that print table already exists, ignoring and adding words, right? So it's going to ignore that error and just go ahead and add the words. If anything else happened, we can say print, oh no, something bad happened. And then we can go ahead and print that E variable, because that's going to be the exception that was caused. And then here we would want to end our program immediately, right? We want to end our program immediately. So we're not in a function right now, so we're just going to go ahead and say exit. All right, we're just going to go ahead and say exit. So again, a recap, right? A recap of what's going on here. Then let's go ahead and add our comments here, shall we? So we're going to try to add our table to the database, right? We want to try to add our table to the database. Maybe I should add it right here. So after we try to add it, this again is in our not an official state, all right? It's executing the statement, but it's not fully going through until we try to commit it, all right? So here we want to push our changes to the table, right? Actually go through and do that official save onto the table. If any of this errors out, if it was a duplication error, a duplicate table error, then we want just to print a little message and continue on with our day. We want to handle it gracefully. So if it was a duplicate table error, then it's going to be here. If it was any other type of error, all right, if it was any other type of error, then just end the script right here. Something went wrong, we gotta go figure out exactly what happened. All right, so if we try to rerun this again, you'll see that now we get that nice little print statement here that says the table already exists, ignoring and adding words, right? Ignoring and adding words. So we're not running that script yet, so we don't have to, worry about that just right now. The last thing we're missing here is, remember, if we look at our little notes here, we got our after table, and I think that was right here as a little note. So we need to run this also. So we can just copy our exec statement here. We can replace all this SQL in here with that, and bam. Notice we can have multiple, like we mentioned before, you can have multiple exec statements in a row, one after each other. That's just fine. You only need one commit. You could add commit after every single one of these if you would like, right? You could add them here and then add them here. It's totally up to you. You don't need to though. I would say just try to do it in blocks, if that makes sense. So for example, this whole block right here is for creating the table. So after we've done all the execution of these statements that we need for creating the table, then you would want to try to do a commit and see if anything goes wrong, right? Then we would move on to the next block per se, where we add the words, and then I would perform another commit. All right, that's how I would personally go about it, but it's totally up to you. All right, it's totally up to you. What questions do you guys have so far in regards to this? So again, all we did was add that extra statement, put this in a try and accept. All right, we have two accepts, one specifically for targeting duplication tables, and we're okay with that. And then another accept for anything else, and we want to just end the program immediately if that happens, because we don't know what happened for it to go to there. What questions do you all have before we chug along here? Yeah, some of you guys might be sitting here like, maybe I should go back to the GUI. Maybe I should go back to the GUI, because this seems like a lot. And again, yeah, it can be. Sometimes the GUI might be faster. It might be faster, specifically in regards to one-time setups, or if, kind of like what we just did right now, which I set up one time, I'm only going to use it one time, and then I'm never going to use it again. I'm not sharing it with people. All right, that it may be faster. It may be faster, but in the real world, it most likely won't be. If you want to share this with your friends, if you want to show off what you're doing, if you want to put it up on GitHub and have people clone your code and rerun it, they have to go download the database software, but are you going to have them like really make it all from the table from scratch? Like, not very many people are going to want to use your stuff. Even if you're a developer, again, developers like being lazy. If something is a nice, easy, like I run once, just works beautifully, I don't have to do anything extra, I'm gonna typically use that more often than not. All right, even if it may be an inferior product, because developers are just like everyone else. All right, just like everyone else, we want to have a nice user experience. All right, we don't want to be messing around with all the little knobs and stuff. All right. So this makes things more like a Ferrari, right, instead of a Honda, right? It's a little bit more luxurious, a little bit more nice. It is a little bit more work for us, but scalability is here, right? We don't have to help as many people because we just tell them, run this script, it will do it automatically for you, all right? Go ahead, Kamal, ask your question. I'm trying to stall for the questions. Are you good now? All right, let us continue. Got rid of my error codes. Perfect. It's running smoothly. Perfect. So let us continue here. So our word list transfer, we did the tables here. So we're missing one. No, this is just going to be for word tables. All right. So now we need to add all of the words, right? Add all of the words. So this is particularly for transferring words from a file to the database, right? From a file to the database. So the next thing we gotta do is, that's right, read from the file, read from the file. Now we could write this up from scratch, but we already have some code that is reading from a file right here. So let's go ahead and copy that code and paste it, right? And paste it. Let's tab this down because it doesn't need to be up that high. All right, and we'll leave a comment, read from the file. So this is going to be reading from our file. Again, all of the lines in the file are going to have all of the lines in the file, each one on their own. It's going to be an array or a list. Each item is going to be one of the words, right? Each one is going to be one of the words, which is very convenient because right now, if I asked you, how would we add all of these words? We have the connection made to the database. We have the connection made, it's ready to go, it's primed up, the table's been there, it's been created, or it's already existed. How do you add all these words? Some people may want to add all of the words at once. All of the words at once. Noble endeavor. Noble endeavor. But that doesn't really work, right? It doesn't really work. You have to actually add each word one at a time individually. And why is that? Great question. Because that's how we set up our table here, right? Our words table, even though it's called the words table, it technically only handles one word at a time. One word per row. One word per row. There's no way to immediately add 1,000 words. You have to add them one by one word at a time. All right? So it's pretty typical for newer devs that are doing stuff with tables that may want to bite on to more or try to do something that's a little on the more impossible side. All right, so just be aware of that. Typically, this is not always the case, but a good rule of thumb is if you're ever Googling and searching for an answer and it seems like a really, really, really large uphill battle for you, you might be looking or going about it the wrong way, right? You might be going about it or looking at it the wrong way. So it might be better for you to sit back and think about what's a different way to approach it, right? So we need to go through every word at a time. We know how long this list is. So what's a good contender for this, loop-wise? Because we know we need to loop and run these statements over and over again. That's right, a for loop, because we know exactly how large this list is. So let's go and do our for list. So we're going to do for word in all the lines in the file. All right. So for every single word in the file, we want to run some type of code. What code do we want? Well, we're going to be running another execute statement because we're going to need to add that data, right? Even better yet, we do have this refer to when adding that we left right here from our example code. So let's go ahead and copy that and paste it here in our for loop. And let's go ahead and uncomment that. I'm going to remove that. So we don't need user input because we have word instead. So we can say word right here. So, and this right now is going to be a select statement. We know we don't want a select statement. We know we want an insert statement because we want to insert the word into the table. Now, this again is where you want to start memorizing those SQL statements because they're going to be on the test, right? They're going to be on the test. They're a part of the requirements listed on the roadmap, right? They're part of the requirements listed on the roadmap. But remember, if you can't recall all of the formatting for the SQL statement, you can always go here in the viewer, right click, generate SQL, and insert statement. And you can go and copy that over. This one is very, very simple, right? Very, very simple because it's only one item. So let's go ahead and grab all of that. There we go. So insert into. We want to insert some data where we want to insert into the words table. So we got public.words here. What do we need to insert? What is required? Well, we just need to insert the word. We don't do the ID because the ID is handled for us auto-magically by the database. And then next we need to say what values we want to enter in. And right now it's just some quotes. Instead, we want that %s, right? Why are we doing it this way? Well, if you've already forgotten, don't forget this. Do not forget this. All right, rewatch our episode or day, what is it, 71, 72, when we talked about this stuff, right? Very important. To avoid SQL injection attacks, do it this way. There's no exception. You should be doing it this way always, period. All right, there's no ifs, ands, and buts about it. You need to make sure you're avoiding simple attacks, right? Simple attacks. All right, so the last thing we may want to do, all right, this is more so for cleaning up, and I think we had to do it in here, right here, this dot strip, right? We're gonna do a little stripping of this word just to make sure it's all clean. All right, what do I mean by that? Well, if you don't remember, strip, if we hover over and look, it's going to give us the word, but it's going to remove all leading and trailing white space, right? All leading and trailing white space, because there is a possibility that there might be a space at the end of the word or at the beginning of the word, or maybe that new line character, that special new line character is being added as a part of the word. So we want to completely remove those before we add them to the database. So we're only dealing with clean, good data in the database, all right? So we got this for loop that's going to go through every single word. It's going to then add all of those words to the table. And then once it's done with this, they're added to the table, but not fully added, right? So we got to do that commit, right? We got to do that commit. So let's go ahead and run our connection.commit here. That way we can fully commit. And if we rerun this, you'll see we get a beautiful error here for a current transaction is aborted. All right, so failed in SQL transaction. So we got a little error here we need to figure out. Before we do that though, we kind of went a little over on time here by like 20 minutes. So I'm sorry. I'm sorry, you guys. So let's go ahead and take a break. When we come back to the break, we'll fix this error. We'll rerun this so it works. And then we'll change our logic in our word guessing game to pull a random word from the database. And then we'll real quickly add the logic right here for adding the high score. All right. And then we'll be done. So we'll be back in 3 to 5 minutes to finish this up. If you have any questions, please put them in the chat and we'll answer them right when we come back from break. I'll see you guys in 3 to 5 minutes. Alrighty, you guys. 1 second here. Alrighty. Let us get back into it, shall we? But before we do, let's go ahead and just finish up with our little intro here. If you're not aware, we are a Rootkit nonprofit organization here in the US of A. Don't go to college. Do not go to any other boot camp, right? They're scams. They're absolute scams. They're not going to teach you what any employer wants, and you're going to be pretty much unhireable. Instead, get certified with us, all right? We're the best in the industry for comp sci certs. Get certified, then get a job, all right? And it's so simple too. If you're watching right now, you've already started. All episodes of 100 Days of Rootkit are available on YouTube for free. Our whole roadmap is up on GitHub for free. To learn is free, all right? You just got to get certified. And everyone that's watching, congratulations, you have a waiver now, and you can take the certification exam for free, and we'll help you get placed into a job directly, all right? Go take a check of the site, go check out some of the perks, and get yourself a job in the industry. On top of all this free epicness we're doing, we have our week 11 giveaway that's up and live now. Very simple to enter, All you got to go is to our site, blog, week 11 giveaway, click on this green button here, enter in your email, and then just prove that you're subscribed to our YouTube channel, following on Twitch. Very basic stuff, and congratulations, you have entries to win some mystery merch. What is it going to be? I don't even know. We'll figure it out together on Sunday during our chill Q&A, where we randomly poll the winner and randomly poll what merch is going to be given away. All right? On top of that, if you like what we're doing and you want to avoid your taxes, well, guess what? We're a charity, baby. All right? Avoid taxes. Donate to us today. Let us be your tax haven. Depending on how much you donate, you can unlock certain rewards, all right? This link is in the description of the video, or if you're on Twitch, somewhere in the About Us section, all right? Where you can unlock rewards like our epic stickers, our exclusive 100 Days of Rootkit stickers, our collab t-shirt, and our exclusive epic sweater. I absolutely love that thing. Keeps me too warm, all right? Sweater, hey, sweater season's almost over, so maybe nab one for next season. On top of that, all donations are matched 1-for-1 for the first 10,000 donations, right? For the first 10,000 donations. Along the way, we have pillars that we're hitting, like streaming for 24 hours straight, shaving my head here live on stream, and shaving my beard, which no one wants to see except for my mom. So that our goal is not to hit that goal, all right? If we don't hit that goal, we're doing good. Alrighty. Let us continue on here. Let's see if RNGesus can do it again. Get out of here, Jimbo. Get. Steal it all. You and, I'm forgetting his name right now. Just stealing literally every single roll I do. Both of you guys. The luck on you guys is absolutely insane. If you win, you have to double it and give it to the next person. That's the rule. All right, fine. If you win, if you enter and you win, I'll double the prize. I will double the price, so we'll do twice as many rewards for everyone else. Like twice as many as is, like if we were giving a t-shirt away, we'll do 2 t-shirts for 2 people, not including yourself, all right? God, sick man. Alrighty, so we left off with an error here, so let's figure out the error, shall we? First step, we gotta read it. So let's read right here. It was an error. In failed SQL transaction. So some type of SQL transaction we made failed. Transaction being sending data didn't work out. Current transaction is aborted. Commands ignore until end of transaction block. End of transaction block. Is it not happy with our word.strip here? It may not be happy with our word.strip here. Before looking in that more, I want to take a quick peek at what we had here before. Just making sure we use the %s correct. So it may be that function we're running. So let's eliminate that issue by just saying temp equals this, and then we'll just have this as temp. And then we'll rerun, and it looks like it's still errored out. So one last thing before we go to the Googles is let's see if we can do the commit. Maybe it doesn't like us. I don't know why it would have an issue with that, but maybe it doesn't like us stacking up all those executes. So let's run a commit at the end of every single one of them, and that's still running into an issue. So what do we do next? We start Googling. All right, let's start Googling what this issue is, and see what we might be running into here, shall we? So we're missing our little P here. Can I go to the beginning? There we go. And let's see what all of the great devs online say here. So Stack Overflow is always a great resource to go to first. This is not exactly the error we got, but we can still take a look at it and maybe it will help us out. They had a database error, but this was the same little message. So we can check it out and see. This is what Postgres does when a query produces an error and you try to run another query without rolling back the first transaction, which means we're doing multiple of those execute statements before resolving the issue of the first one. All right. So do we need to do a transaction.rollback? Maybe. Let's go ahead and see if there's anything wrong with our query statement if we go to the database itself and try to run the SQL, right? So we're going to just enter this in, and for values, we're just going to put in a word here. Let's do hello, and let's try to execute this. And here we go. Hello column does not exist. That would be an issue. Hello column does not exist. Is it because it doesn't like the double quotes? Let me do single quotes here. Hello column. It thinks this is a column. That worked with single quotes. It got inserted. Let's go to our words here. Let's go and refresh. Hello is in here. Interesting. Interesting. Let's double check the generated SQL that we got here. And that's going to be single quotes. Now we shouldn't need single quotes around our string here, but maybe we do for this instance. So let's just put single quotes around our %s. I would be confused if this worked because it should just, or maybe it's because of, ooh, is it because of this? Oh, it might be because of this part. Let's run this and see if this resulted. I don't think it's going to. Yeah, it didn't. Oh, yeah, now it has double of the quotes. So let's remove those quotes. So what I'm guessing what's going on is because we're creating a table here and it's throwing an error. It's throwing an error when we try to do that dot commit. And it's not very happy right now. It's not very happy at all. Everything's kind of in a little messed up of a state. All right, it's a little bit messed up of a state. So we have to do that rollback thing we saw on our Googling here. Let's see if we can re-pull that up. Let's go to history. So even though this was not the error we were looking for, it still came in a little handy, right? It still came in a little handy because this part right here told us that when a query produces an error, any query, right? We're doing queries, it's producing an error. We may need to roll back the last transaction, all right, in order to get everything in a good and proper state again. So if we do some looking around here, we're not using Django, but we are using con. So it looks like we can do potentially this rollback command, or this person right here says there's con.rollback that we could just run straight up. So you can go about experimenting with what works for you. I'm going to try to see if this one is here first. So what we can do is if this messes up and now everything's all a little kind of funky with the database connection, and we want to continue forward right here, this is where we would want to put that con.rollback. Here we go. And it doesn't take anything to run it. We just run this and it should technically fix everything. Let's see. Let's see. So let's rerun. And look at that. Like magic, it fixed it. It worked. It ran. Let me go ahead and clear and rerun this. It says that the table already exists, ignoring and adding words, and it worked. And it worked. All right? Because the connection to the database got a little messed up because we were trying to add a table that already existed. So it kind of messed up our connection. So doing this rollback here fixed it. Now, I made it look kind of simple for finding that solution, which it can be, but again, this is why we teach you guys all the foundations. And if you're just joining now, new to the 100 Days of Rootkit, we're on day 74. There are 73 other days where we covered foundational items. Those foundations are super, super important, especially when you're trying to diagnose issues like this, because newcomers who are just getting into programming and learning about databases, this may be confusing concept, and you may see solutions online, but they don't really make sense, so you might skip over them. All right, so it's kind of combining some of the foundational elements and your Googling skills to hopefully come up with solutions, right? Hopefully come up with solutions and think about things. Because again, all computers work the same. All languages are pretty much the same, all right? So anything you learn in one most likely will be applicable in the other. So knowing those foundations are very important because that's the foundations of computing, right? So anything that's a foundational item is going to be foundational to pretty much every programming language, all right? So for rollback, this you can infer from, the commit logic. It's kind of like Git. In Git, there are ways to do rollbacks in there also. So you can do rollbacks in this, right? You can do rollbacks in this. This is great. If we look at our database right now and refresh, you're going to see we have all of our words in here. We have all of our words in here, a lot of words. Additionally, we have more words than we do in our actual list. Why? Because every time you run this, it's going to add all the words to the database again, right? It's going to add all of the words to the database again. This is where something like adding a constraint for the word might come in useful. We're not going to do it, but you can. You can add a new constraint here. Instead of primary key, there's a unique key, which means that every word that's added must be unique. All right, you cannot add the same word twice. So that may be something that you want to look into and add. We're not going to add in this example because things are kind of messed up right now. But what I will do is I'm going to completely remove this words table. So I just deleted it. I no longer have a words table in this database at all, period. And just to show off our script here, when we rerun it, it ran successfully. And now if we look at the database here, the table doesn't show up still, all right? The table doesn't show up still because we have to refresh our connection. So I'm going to right click on the very top here and click on refresh. And you're going to see the words table is now in here. It got automatically created, and it got automatically created correctly. And all of our data was added in here instantly in a split of a second. That's the super powerful thing about writing these scripts, right? Writing these scripts. Now you can share it with people and they can instantly get the tables generated that they need to get generated. Any questions about this before we move forward? Since we're running kind of low on time right now, we might space this out for tomorrow also. So what we'll do is go and ask your questions if you guys have any questions. I see you have a question there, Kamal. I'll look at it here in just a second. What we're gonna do is we're gonna do some organization. So we're just gonna move the files around, organize a little bit, so it's not as chaotic looking in this folder. And then we're going to make it so our word in our word guessing game is selected from the database, and then we're going to call that good for today. Tomorrow we'll finish up the word guessing game, and then we'll start working on our dungeon crawler game. All right. So let's see here, Kamal. For file equals open word list. Yes. Which word list file is it opening for you? The file called word list. So I have a file literally called word list right here. So you can point this to any file you want. Again, I copied all these words. You guys may have not copied all of them. You may have just mainly entered in a couple of them. That's completely fine, right? You can do that too. You just need some type of file with at least one word in it, right? At least one word in it. Any other questions before we chug along here? That means it was deleted. If it's still there, don't worry about it too much. I think, which this is my bad, I didn't think we hit get on this one. That's a get thing because of get. Okay, it looks like we were using get on our word guessing game. I forgot, so we have not been doing get commits at all. So we'll do that a part of our cleanup, and that will get rid of that red glow on that file for you. Don't worry about it too much though. All right, it's not that big of a deal. The file is still there. You can visually see it. It just means that Git was tracking that it was deleted. Alrighty. I don't see any other questions. So we'll continue on here with our organization. Things are starting to look a little crazier, a little sloppy. We got some notes here. We have a README here. We have our save file here. We have a test file, which we don't really need anymore. So we got our word guessing file and our word list file. So it would be great to organize a little bit here. We know we have a script right now, and we most likely will have another script here in a second for auto creating the tables and adding data to our database. So maybe we make a new folder in here called startup, and this will hold all of our startup scripts. So this would hold our word list transfer script. So let's go and move that to the folder. It would also hold our word list, so we can move that into the folder. Close all orders. And let's see here. We have our database update, which were kind of notes for us. So we could have another folder in here for notes if we wanted. I think I might just put this in the startup folder for right now. And just annotate. Yeah, we'll just throw it in the startup folder because it was just our notes on how we would create the databases. We could potentially translate some of this info to our README, right? Generally to our README if we want later on. Save file, can't do too much about it because this is where we were saving our data. The test file we don't need anymore, all right? So we could either delete this completely or move it to a folder called testing where we test things out, all right? Totally up to you guys. I'm just going to delete it for now because I don't think we really need it. And there we go. There we go. The last thing we're missing here, because this is a Git project, right? This is a Git project, which I forgot about. We need to do some Git commits here, but we don't want to be Git committing our save file, the saved information here. It makes no sense for us to commit this up. Right? This is for us locally. So what does that mean? We need a get ignore file in here. So let's make a new file in here called .getignore. So we can ignore certain files. So we're gonna ignore files that are called saved. All right. So we're just gonna put that in there and do Control S. And you'll see that saved kind of gets grayed out now because it will no longer be pushed up when we git commit. And let's see here, that word list file, we don't want to push that up either. We want everyone to be adding their own word list. So let's go ahead and add word list to this. And there we go. That word list file is grayed out because we want people to add their own word list. And looks like everything else we probably would keep. So let's go ahead and do a git add to add everything, right? To add everything. And then we're going to do a git commit so we can actually save this to our Git repo. And if we look here, we can see everything that's going to be added. So the git ignore file is going to be modified. Our startup database update.txt is going to be pushed up. And our wordlist transfer.py file is going to be pushed up. All right, seems about right to me. So I'm going, whoops, I need to actually add a message here. Added the db word list table generator script. And we'll go and do git push. So it all gets pushed up, right? So it all gets pushed up. Sweet. So this is all pushed up and we're ready to just continue chugging along here, right? Continue chugging along. So let us go back to our word guessing game. Because the last step for us here today, and we'll continue tomorrow, is to make it so this is no longer reading from the word list file, right? Technically, our program will error out right now because there is no word list file anymore via this relative path it has, right? So we need to connect this up to the database. So what we can do here is we can go and grab our connection information right here, copy, go back, and do a paste, right? Do a paste. I'm gonna remove, I'll keep these comments, I guess. So we need to start adding this and replacing our previous logic. So we first need to connect to the database. And then we can go ahead and end our connection to the database. So we'll do a close right here. And in between, we need to do our statement, our SQL statement. We know to do a SQL statement, we have to do it off the cursor, and it needs to be a cursor.execute, right? Then we can add our SQL statement in here. Additionally, when we are performing our SQL statement, it's always a two-step process. If we're adding stuff, it's going to be execute and then commit to officially save it. If we're getting data, which is what we're about to do, we're going to get a random word, we need to perform an execute and then a fetch, right? Two-step process. It's always a two-step process. So we're going to need to do some type of curse.fetch and then one, because we are only going to want one result. Now the question is, what statement are we going to run here? Because we know that there's the select statements, which is for selecting some data. We've showed how we can select data, a bunch of data, but we never really showed how to randomly get data. More so, is it even possible to ask the database to randomly select some data? All great questions. When you have questions for like this, what do? That's right, call Ghostbusters. No, you go to Google, or I guess Bing, all right? Because Bing, oh, thanks for the follow. Neffy guy. That Neffy guy. Or, I mean, if you're not already, you probably should start using things like Codex or GPT, all right, in whatever form you want. Codex is, I guess, one of those forms, to help assist you, because you could ask questions from it in order to get the answers, all right? Use these things to help you, all right? You're not cool if you're doing it because the rogue old-fashioned way, all right? No one cares. Everyone cares about results, all right? So get results. Use the latest and greatest. We're just going to use Google, all right? I guess we're kind of a little old-fashioned here. So let's go and Google Postgres, because that's what we're using. Get a random random row. Select a random row. So let's even see if this is possible. It looks like people have asked it before. And it looks like a basic implementation using random is in Postgres, potentially. Let's see here. Now, I don't know if this will do what we need it to do, because random looks like it's just going to... I don't know why this is so small for you guys. It looks like random is just going to generate a random number for us. And by default, a lot of times these random numbers will be floating point numbers between 0 and 1, right? 0 and 1. This is going to be a double, not a float, but the same thing, 0 through 1. This doesn't help us get a random value from our table, though. This can potentially help us, but it doesn't get us a random value. So let's see if they have some examples here later on. So again, if you're searching and looking through this yourself, make sure you're reading all this. Make sure you're reading all this. We're going to just skim through it real quick to see by order random. Wow, is that really a thing? We could do that. We could definitely do that if that works. I'm learning something new today. All right, to be honest, I didn't think it was gonna be possible this way, but I guess it may be. Okay, let's try this. Let's try this out. So you could try this out immediately in the code, or since we have the GUI, we can run SQL statements directly inside of there. So we can just copy this and run it directly in there. So I'm going to copy this one, which is select everything from our table and order by random, and then limit, and I'm going to have this limit 1 because we only want one item to be returned. Order by is another special term that you guys need to learn for the exam, right? It's a part of the roadmap. And this is a way to sort and order your data upon returning it. So maybe you want it in alphabetical format, or reverse alphabetical, or maybe by age. This is just a way to order your data when you're returning it. All right. So apparently saying we can do it by random, we'll see here in a second. So obviously this is not going to work directly for us in our database. We're going to have to modify it because we don't have anything called doggy. All right. So just remember, you're going to have to adjust these things. You're going to have to adjust these things. We don't have any table called doggy. Ours is called public dot, and we want words, right? So order by random, let's do limit 1. So let's see just even if this works in the first place. So let's go ahead and execute. And it looks like it works. It looks like it's worked. Let's run it again and see if we get a different word. We got peace. We got peace for this first one. And we got again for the second one. Hey, that's pretty nice. That's pretty convenient. All right, that's pretty convenient. This is 100% working for us. This is 100% working for us right now, right here. So we can use this one. We can use this one as our SQL statement. So let's go ahead and copy this. Go over into our program here, and in execute, we'll go ahead and paste this. All right. Remember, we're just going to fetch 1. We're limiting, so we just get 1. But additionally, we want to only fetch 1 because we always have to fetch. And we're going to say this is the word, right here, we're using selected word. So we're going to call this one selected word equals. All right. And let's go ahead and print out our selected word. Selected word. And I'm going to exit the program right here. So all we're going to do is when we run our word guessing game, it's going to connect to the database, get a random word, and print out what that information was. So let's go ahead and Python word guessing game. Sweet. So we got one item. It was start. And if I rerun this again, now it's decided. So it's random every single time. Very, very awesome. Very, very convenient for us. The only thing is, again, you're going to get a tuple of results from your table. Since we're selecting everything, we're getting the ID, and then we're getting the word. So the word is always going to be our second item here. So we can just go ahead and say that we just want the second item. So we're going to say cur.fetch1. This is an array. So we're just going to go ahead and do our brackets right here. And we're going to say we want the, not the first item, but the second item out of it. So when we rerun this, you're going to see now we get that word and that word alone. We got pencil. Sweet. So this is now fully functioning. So if we remove this exit right here, we can now remove this old logic of opening this word list file, getting a random word and assigning it to a selected words, right? We no longer need all of this because now our database is doing it all for us. So we can delete all of that old code, right? All of that old code. And now, there we go. Now we're just using our database instead, which is super, super awesome. The last test is to run the game and see if it actually works now with all these adjustments. So let's go ahead and try it. Let's run. It looks like it's working. We kind of got the answer printing out here because we didn't remove our print statement from right here, but it looks like our word was straight. So we have 2 attempts left. We have 0 score. So let's go ahead and do STRAIG. There we go. We've won. And we got to enter our name for the high score list. Looks pretty good to me. Looks like it is a fully functioning program that is fully connected to our database and ready to go. Let's go ahead and remove that print statement. That selected word there is for testing. The last thing for us to do here is, of course, do our git add all and then our git commit and then say connected to DB for selecting a random word. All right, a little message for our commit statement here. We'll go ahead and push that up so it goes and syncs up with the remote server. And now we're good to go. We've made progress. We've made progress. We've logged that progress, saved it, published it. Now we can go home for the day, chill out, and know when we come back to work tomorrow, we can just continue where we left off and get ready for this game to be fully released to our customer with full DB support. All right. We're just about ready to end today's lesson. Any questions you guys have before we end today? Go ahead and ask your questions. While you guys are asking those questions, again, tomorrow we'll go ahead and finish up this program. I didn't expect to take this long on it. Sorry, you guys. So we can do the saving, right? The saving of who won to the database. And then once we are done with that, then we'll start doing dungeon crawlers. We'll start integrating dungeon crawlers with the database. All right, so we can kind of see that flow there. And dungeon crawlers is a more complex game. There's more data in it. So we should be potentially using more complex, table setups. So hopefully this was super useful for you guys. I don't see any questions rolling in right now. So remember, if you do have any questions later on, you can always go to the Discord and ask any of your questions here in the 100 Days of Rootkits chat, and we'll answer them anytime you guys would like. And remember, every Sunday is Chill Q&A, where we're just sitting here, not learning anything new, chilling, answering questions. So if there is nothing else, then we'll end today's session. And I'll see you guys tomorrow on the next one.